Welcome to Thrill Science. Today we're going to talk about Earth science, specifically everything in this list. But this will be too long and boring, that's why we are here to help you understand these topics in an enjoyable way. We are going to divide these topics into 5 portions: weathering rocks, Earth's magma, behavior of rocks and minerals, layers of the Earth, and finally, the structure of the Earth's ocean floor. Are you ready? Let's begin. Have you ever wondered how rocks break down or dissolve even though it's as hard as your crush's heart? Wow! Just kidding. But seriously, even though rocks are really hard, they could be still broken down. These are the agents of weathering: water, ice, acids, salt, animals, and changes of temperature. The moment that the rock has been broken down, erosion transports bits of rocks and minerals away. Weathering wears away exposed surfaces over time. This is also the first step in the production of soils. Teeny tiny bits of weathered rocks and minerals are mixed with plants, animal remains, fungi, bacteria, and other organisms. A single type of weathered rock often produces infertile soil. Fun fact: there is no rock on Earth that is hard enough to resist the forces of weathering and erosion, not even the largest one. While weathered materials from the collection of rocks that's richer in mineral diversity contributes more in fertile soil. An erosional process called mass movement moves rocks and sediments downslope due to the force of gravity. These are transported from higher elevations to lower elevations, where transporting agents like steam and glaciers can pick it up and move it to even lower elevations. Some mass movements processes act slowly. Some appear suddenly, but often with disastrous consequences like earthquakes and landslides. Moving on to the next topic, Earth's magma.
And here's the main topic of portion 2, magma. Magma is an extremely hot semi-liquid rock located under the Earth's surface. Magma forms from partial melting of mantle rocks. As the rocks move upward or have water added to them, they start to melt a little bit. These little blebs of melt migrate upward and coalesce into larger volumes that continue to move upward. They may collect in a magma chamber or they may just come straight up. Magma developed within the mantle of crust where the temperature and pressure conditions favor the molten state. After its formation, magma buoyantly rises toward the Earth's surface due to its lower density than the source rock.
Let's discuss the behavior of rocks and minerals. Nevertheless, what exactly are rocks and minerals? Rocks, as we all know, are made up of one or more minerals and sometimes mineraloids, but they lack a crystal structure. In contrast to minerals, rocks lack a clear chemical composition. In the mineral is a naturally occurring substance with a crystal structure that is typically solid, inorganic, and denoted by a chemical formula. Different chemical mix-ups in minerals determine their crystalline form and shape. Now I'm going to describe the changes in mineral components and texture of rocks due to changes in pressure and temperature. The metamorphism. When a rock is exposed to conditions like temperature, pressure, and chemical environments that are different from those in which the rock first formed, it undergoes metamorphism, which is described as the modification of mineral accumulation and quality. And now, how do rocks behave? Well, rocks' behavior is determined by the type of stress they are exposed to, and there are 3 primary types of stress: the compression, the tension, and the shear stress. Compression. Compression is the most frequent stress at convergent plate borders. The act of compression involves the pushing in of rocks from all sides. The lack of a moving surface prevents the rock from bending. Rocks are compressed to together by compression stress. Rocks can fracture or fold as a result of compression stress. The tension stress. The tension is the stress that tends to pull something apart. It is the stress component that occurs from forces applied perpendicular to a specific surface, such as a fault plane, or from remote forces communicated through the surrounding rock. The rocks pull apart during tension stress. Rocks extend or break apart due to tension stress. Finally, there's a shear stress. It is the stress component parallel to a particular surface, such as a fault plane, that comes from forces applied parallel to the surface or from remote forces communicated through the surrounding rock. As tectonic plates pass one another, shear stress develops, forcing rocks to twist or take on different shapes.
Ever wonder what is beneath us? Well, the crust, mantle, and the core make up the Earth's structure. Let's talk about first the most significant part of the planet's interior, providing the environment, natural resources, and geological hazards that affect humanity, the crust. It consists of all types of rocks, soil, and everything you see above the Earth's surface. Moving on, below the crust lies a layer of very hot, almost solid rock called the mantle. The thermal and mechanical driving factors for plate tectonics are provided by the Earth's mantle, which also plays a significant role in the formation of the crust. Beneath the mantle lies the core. The Earth's inner core is made up of superhot liquid molten substance called lava. The lava is believed to be made of iron and nickel, and it's also the hottest part of the Earth as it is as hot as the surface of the Sun. Moving forward, what supports continental drift? Well, the continent's puzzle-like fit, the scattering of old fossils, rocks, and mountain ranges, as well as the locations of the former climate zones, are the four pieces of evidence for continental drift.
Structure of the Earth's ocean floor. Do you know how the seafloor spreads and the movement of plates leads to the formation of folds, faults, trenches, volcanoes, rift valleys, and mountain ranges? Let's talk first about the structure of the ocean floor. The ocean floors can be divided into the following major divisions: continental shelf, continental rise, continental slope, abyssal plain, trench, underwater, mountain range, volcanoes. What is the Earth's basin? The ocean basin forms initially by stretching and splitting of continental crust and by the rise of mantle materials and magmas into the crack to form a new oceanic lithosphere. Among the major ocean basins, how does the evolution of Earth's basin form a new structures in the ocean floors? These are 6 stages of evolution of the Earth's basin, and these are embryonic ocean basin, juvenile ocean basin, mature ocean basin, declining ocean basin, terminal ocean basin. Suturing these stages helps to build new underwater landforms due to tectonic plate movements. Plate tectonic movement, weathering, and erosion all contributes to formation of ocean basins. The two main types of plate tectonic activities, these tectonic movements, helps the Earth form new structure. When tectonic plates move, it gives molten rocks to rise and build a new oceanic crust, leads to the formation of folds, faults, trenches, volcanoes, rift valleys, and mountain ranges.